Sorry for that interruption. So we started with types of machine learning, and we said there are principally two types. So we have supervised machine learning and unsupervised. I would say the supervised machine learning uses labeled data. Now, what that means is that you, for instance, looking at the data we have been dealing with, most often that's supervised data. Data we've been dealing with, we take data, we say the dependent variable is this, we have independent variables, this, and the rest, right? Okay, Asha. Yes, that is the concept of supervised machine learning. And so we have our inputs and we know what we are expecting to get. There's an expectation of the output. So we want to predict an outcome. For instance, we know the outcome. The situation where we said the situation we said decide whether a loan will be granted or not is a case of what? Supervised. Because we know that the loan should be given. The case of where maybe we don't know exactly the outcome, then that will be unsupervised. So with unsupervised machine learning, the underlying ideology is that the machine studies and identifies patterns. It just studies the situation. We give the data with that a specific outcome. We are not saying that tell us whether the loan will be given or not. We are not saying that this is what we're expecting. Maybe study this data. In the case where we say rearrange this room. And so we just want to know they will arrange them. How they will arrange it, we don't know. Right? Are they going to use chairs on one side, tables on the other? Are they going to put what equipment and what direction? We don't know, but we just know that they will be able to study and identify things that are similar, things that are different, and so on and so forth. So for instance, we could use this to maybe get patterns that under normal circumstances you will not know. I basically assume that for take a situation where you are doing marketing, and so you decide that you can Boya yes, you're dealing with Boya. But when you start studying from an unsupervised perspective, and discover that okay, we have Boya, but you want to Boya is not generally divided into maybe molecule, this and that, or let's say you're doing molecule, data south, checkpoint, and the rest. That's the segments. But in course of studying using the unsupervised approach, they may not break Boya in terms of data south. They may not in terms of molecule, may bring up new in terms of they can say, okay, let's break in terms of those who are living outskirts, those who are living this, those are patterns that you might not have thought that your clients are classified in that dimension. We can say, okay, those who are with certain income, because they see the patterns, right? You give different variables, their locations, their income, their this, their that, and so they just study and said, okay, we can group people based on income level, we can group people based on this, we can group people based on, and go to other variables. There's no grouping, so they'll decide using, they can use income, location, age, and bring up a new group of people. This, and bring up a new group, a new dimension. So in other words, with unsupervised machine learning algorithms, the objective is to discover patterns in the data set that we will not commonly identify with our normal existing algorithms or with the supervised. Because the supervised, we already know what we want, and we want to get exactly what we to or to confirm what we want. But we unsupervised, we don't know what we want, but we believe that it has the potential. And so I think from supervised, you can easily get hidden patterns. And that's how it works. Now, the issue of reinforcement learning, which is another category, is that the AI studies by interacting and interacting with the environment. Now, what does that mean? That means that, for instance, let's say you are teaching a dog. Basically, it's a good example. You're teaching a dog how to understand, maybe to do an activity. So, how this works is that when the dog gets the right thing, you reward the dog for succeeding. But when it fails to get the right thing, it is penalized or punished. Penalized may mean that if it gets the right thing, you give the dog food. If it doesn't get, you will not eat. Right? So it keeps studying. So when now you say, okay, we have trained the dog, and you say, okay, for instance, you ask a question, ChatGPT gives a wrong answer. You say you dislike it. When you ask it, so it's like penalizing. So that you should know that's a wrong thing. And next time it will not. So because of the punishment, it tries to ensure that you learn fast to be able to do the right thing. That is how reinforcement learning. So by interacting, by associating now, you know that, okay, for instance, or you are entering that things are just packed. You need to pass, and but if you hit yourself on the table, you go back and start. Anytime you hit a table, you go back, or anytime you hit a table, you go back. So you try as much. If a new obstacle comes, you should be able to identify the new obstacle and bypass, right? Whenever you meet an obstacle and don't, like even the safe driving, I think they use the same principle. When a car is moving on the way and if something comes that you need to either stop. If you hit something, you are punished. If you go through something that was new that you did not know it successfully, you are rewarded because you did not see this device. You have not seen this device before, but you saw it for the first time and was able to rightly classify it as what is a wrong thing. I should not hit it, or I should pass sidewalk. That's the concept of reinforcement learning. Okay. Any question? So common applications, we've been discussing the fraud detection, image recognition. Yes, this is where the whole concept of AI started. Somebody should not be, we talk of spam emails. When Google started trying to identify spam emails, try to identify, initially the training, you used cats, train animals. We bring cats, we bring dogs, we bring this for it to study. You know, want to study a cat. That's when you know that there are so many features in a cat that you never know. Right? So if you study a cat, you can study a cat based on the size, right? Yes. You study a cat, you can use the size. You know, the cat. How will you differentiate a cat from a dog? That's a good way to look at it. How will you differentiate a cat from a dog? Size is just one. If you don't use size, what will you use again? The fur and the whisker. The fur and the whisker. And yeah, how are they different? The dogs do not have whiskers. Okay. Whisker are the things here. Ah, okay. So, but the cat does. What about color? Yes, color. Anything that is white is highly likely to be a cat than a dog. But although we have black cats and we have white dogs, right? Yes, the length of do we call the hinds or legs? Yeah. No, for cats, they are short. And for dogs, they are. But now but the chance, that's where it becomes a little bit complex. What if it is a small dog, like a puppy? Right? How do you call it, puppy? Right? The size will be similar because we use size. We did not argue when we are dealing with size. What are we small dog? With the size not be like a cat, right? So what are we saying? That is how AI studies, and you see the complexity in AI to be able to make out these differences. When if you were to tell the dog, to tell the AI what to look for, what will you put that they should look for as differences to classify whether it's a dog or? Because there are some things that will. Yes, when you send a picture, if you were to define what this, take from the perspective of a supervised machine learning algorithm, it means if you want, you teach the algorithm or the model to understand what a dog is by telling, yes, that this is what the dog constitutes in terms of this, in terms of this, in terms of legs, in terms of height, in terms of size, in terms of this. But the problem now is that if you use size as an example and say the size should be big and so, what happens when it's a small dog? You get it? So what unsupervised machine learning does is that there are patterns you don't know that AI will be able to, that the machines will be able to, using data, will be able to identify that are not visible maybe to you, but that they can predict and use to differentiate a dog from a cat. That's a power that you see where a mark different from human ability and machine's ability, because they have the tendency to take on all the nitty-gritties. In the course of studying, they may discover that the length of the furs for a dog are a little bit longer than that of, that's something you will not know, just know that difference. You may not know that, right? They may discover that apart from the length, there's so many minute things. Maybe the colors, the eye colors can play a role. The eyelid will play a role that you will not be able to pick out as a normal person. So that's where unsupervised comes in as a good alternative for supervised machine learning. Recommendation engines, search engines, for movies have been a cardinal part. And so you're able to. So those are different applications. Then we have the machine learning workflow. Now, the machine learning workflow is basically the same as the data analysis workflow, data science workflow, as you can say. Start from data collection. You must collect data, right? Yes. And as we said earlier, data is collected from different sources using different tools, database, questionnaires, interviews, normal, everything from text, pictures, videos, from environment, the atmosphere, in all sensories. We can enumerate all where we can get data from AI. Any human activity is producing data, and that data can be tracked and used. Once the data has been collected, the next thing is for you to now build a model. To build a model, yes, data, obviously, it's not. Data cleaning is an integral part. Yes, that's how we talk about data processing now. Data collection and pre-processing was taking the account of data cleaning.
In this picture here, is it machine collection?
Pardon?
Machine collection. Is it collection?
Machine model training.
Before model training.
Ah, that should be collection.
Yes, and then the second one, model training.
Training. No, it's just model training. They forget about the other parts. It's making a little bit complex. Okay. But if you see from here, it's a model training and
The selection and training.
Yes.
Okay.
Yeah. So we have different models that we can train, which we'll see once we have collected and we have cleaned the data. Depending on your problem, you have to choose the appropriate algorithm or model and train the data. Algorithms are the different data statistical techniques.
Like regression.
Like regression. Regression is one example. We say, why is a function of this, y is equal to b 0 plus that. That's a model or an algorithm that needs to be. So once you pass that model, they study the patterns and understand, and then you can evaluate for effectiveness, efficiency. So we use different metrics: accuracy, precision, recall. Those are core elements that we'll see. Now, generally, when you are doing predictions, there are 4 possible outcomes in any that you can have. That gives us a quadrant that you may have. The first is that, let's take the case of the loan that we saw so that we may use an example. So if you're a loan officer and you invite Madam, the moderator, as a data analyst to come and build an algorithm for loan prediction. After the algorithm has been built and deployed, what happens is that there are 4 possible things that may happen in the course of prediction. Now, somebody may come and we say that they should predict whether the person will pay back the loan or not. The first possibility is that the algorithm successfully predicts that this person will pay back the loan, and the person pays back the loan. Right? Yeah. That's the first possibility. And so, in that case, that is what we want to see, right? Mm-hmm. Yes. We want to see that our model predicts exactly what we want. The second possibility is that it predicts that this person will not pay back when the person has the possibility to pay back. Mm-hmm. Right? Mm-hmm. Yes. Or let's use that, assume that the machine can predict that person paid back when the person did not pay back. Right? So we know that the person paid back and the person paid back. That's the first outcome, and that's our expected outcome. Mm-hmm. Right? The second thing we may face is that the machine, the algorithm predicts that the person did not pay back while the person paid. That's a wrong. So, if the person pays back and we know that the person paid back, it's a good, that's unexpected. The second situation, we have said the person did not pay back and the system said the person paid back. That is an error. The third situation is that the person did not pay back and the machine predicts that the person did not pay back, right? The person did not pay and we know that the system also decided the person did not pay. The last is that the person did not pay and the system said the person paid. So the first was the person paid, the system said the person paid. The second was that the person did not pay and the system says the person paid. The third is that the person did not pay and the system detected that the person did not pay. The last is that the person paid, and the system detects that the person did not pay. Are you seeing the options? Yes. So that brings us what we may call a quadrant, which is, we'll see it as we make progress. That's what we call the confusion matrix that captures this out. The confusion matrix, like the word confusion, right? It's a matrix that is confused actually. Yes, which is more or less a quadrant that gives us the different dimensions. For instance, we'll see they'll talk about true positive. We'll see true positive. True positive means, like we say, the person paid and the student tell the person paid. That's true positive because you get the right outcome, right? The right prediction. Now, true negative is when the person did not pay, true negative, and the system detects that what the person did not pay, right? False positive is when the person did what? Did not pay, but the system predicts that the person paid. Positive, right?
Is when the person did not pay, but the machine says that the person paid.
False positive, yes. What? I think. Then false negative. The person paid, but the system said the person did not pay. So true positive, true, false positive, true negative, true. So our objective is always to, we want to maximize true positive, right? And also, if the next will be to also get right values for true negative. If the person did not pay and we know that the person did not pay, it's also good, right? Yes, so that's the concept that we see in terms of model evaluation. We'll see more as we make progress. The ability for a model to correctly predict, that model evaluation. It leads us to what we call accuracy, veracity, and sensitivity. We have accuracy, veracity, sensitivity, and precision. When we start implementing, we'll see more as those concepts go. Now, the last part is deployment, or deployment and improvement. What's the idea behind deployment? Deployment means when you have done everything in your computer, you have developed, you have collected the data, you have cleaned the data, you have built the data, you have tested your algorithm, you need to take it now to the field, to the production center. If it was for a company to predict whether a customer will pay or not pay, you now institute whether it's a software system. Or if it was the bank, you go now and say, okay, we build now an algorithm so I collect data. Whenever a customer comes, you fill this form. Maybe you fill the form online and the system automatically says, no, you're not eligible for a loan. So you don't even have to waste time and come to the bank. So that's deployment. Continuous improvement. You keep modifying, keep fine-tuning until you get the best. Although you never get the best because prediction, to get 100% accuracy is a problem, right?
Yes.
So that's the concept of model machine learning workflow. It's exactly the same concept that we were explaining in data science, from data collection to data cleaning to data and communication. It's the same thing, just that there's some little modifications. So I think we've already talked about machine learning. I mean, the types of machine learning or machine learning fundamentals. So, like I said, there are new models that are coming up where we have now semi-learn, semi-supervised models. With semi-supervised models, what happens is that we combine both label and unlabeled data. We can say these are tables, these are chairs. Then the system looks for the rest and make predictions. Reinforcement learning, a core aspect is that interact with the environment and then learn, punish for doing wrong, rewarded for doing right, so that it keeps improving and improving. So Some examples of supervised machine learning algorithms will be regression, whether it's linear regression or logistic regression or whichever regression. They are what? Supervised machine learning algorithms. We have support vector machines. We'll see it. We have, apart from support vector machines, we equally have k-nearest neighbor, which we'll see. Then we have still under supervised machine learning, we have classifier. Now, these other ones they do predictions. Prediction means you come up with an absolute value. For instance, what will be the sales for next year? When we this and that rainfall, it gives you a specific value. But with classifier, there are multiple categories, maybe one or two categories that you expect that something should fall in one group or the other. So the case of the bank, it will be a classifier. But if you wanted to predict how much should be given to you based on your current, it will be a prediction model, right? Which we can use linear regression. But if we wanted to do but a classifier, we can use now logistic regression and say whether you belong to those who pay or those who don't pay will be a classifier. But all of that falls under what? Supervised machine learning algorithms. So amongst the many classification models that we have binary. A good example is binary logistic regression. We also have decision tree. Some of you know about decision tree. Do you know about decision tree? Decision tree. Decision tree is we want to decide something. We keep asking questions that are two.
Yes or no.
Yes, kind of yes or no.
Yes.
For instance, we want to find out whether somebody has stolen. We say, were you in class on this day? The person that says yes. If something got missing in class, somebody who says no, we ignore. It means the person now wasn't, should not be part. So somebody who say yes, we say, were you in class at 1 p.m.? We have yes or no. Yes. If that's when the thing got missing. Did you do this and that until we get to the person? So that's decision tree. Now, apart from decision tree comes, we also have what we call random forest, which is a collection of different decision trees. So we'll see some of them. Random forest. That's the case of binary. And we say that the classification is based on the fact that groups are mutually exclusive. We know what it means by mutually exclusive, right? Independence of observation. If you are in one group, you cannot be in another group, so you must belong to one group. We have multi-class. Now, we may not have only two situations, we may have maybe three categories. Maybe agree, disagree, and neutral. So become multi-class. And then items with multi-class membership. And we'll talk about imbalance. Imbalance classes, for instance, we may have a situation where our algorithm or our model tends to be more dominated in one side. Now, if you look back the case of the bank that we mentioned, or a case of a disease, take the case of COVID-19 as an example. If you wanted to build a model to predict whether somebody is vulnerable for COVID-19, you have an imbalanced class because if you come to a country like Cameroon, maybe just about 500 cases of corona would have been reported, but we have billions of people. And so you see that we have millions of people. So we are comparing maybe 10 million against 500. So we have that class imbalance. And so because of that class imbalance, there's always a tendency that the algorithm might function poorly. And so it becomes a challenge. There are ways to handle that, as we'll see. So some examples of classifiers or classifying models or algorithms, we have logistic regression, we have support vector machine, which we'll see. We have k-nearest neighbors. And then we have decision tree, as we have already mentioned. KNN. That's K nearest neighbors. Any question? So with unsupervised machine learning, as we have said, the data is not defined. And so the algorithm learns on their own and identify the patterns. So what happens most often is clustering, which is grouping. Remember when we are doing data sampling, we said we should cluster the different sampling methods. We talk of stratify, and one was clustered sampling. Clustering means group people together that are similar or share the same attributes. Right? So grouping similar points together. You mentioned grouping tables together, grouping chairs together, grouping things that share the same attributes. And so we read enforcement learning. The core aspect, as we have already indicated, is about learning from the environment. We talk about an agent. An agent is like the dog that is learning, going through the process. You try, when you get it right, they give you a reward. When you get it wrong, you are punished. And it helps us now to come up with different other models like robots, autonomous driving, some scenarios where this reinforcement learning comes in, especially in the case of robots. If they're doing the things according to expected, they are rewarded. When they miss, they are, and so we come to what we call artificial neural networks. This artificial neural network basically tries to mimic human brain. That the brain functions because of neurons, electrons, and perceptrons, or how they call them. It is the interaction of this that helps the brain. So it tries to study everything around to be able to make that predictions. So, any question with respect to what we have seen thus far? Any question? Any question? Any worry? Okay.
We'll dive into the proper understanding.
Okay. So, if that is it, we may end here for today. Continue next class. Today's Friday. Have a class tomorrow. Good morning. Okay. So let's continue tomorrow.